I'm Michael Krasny, and I want to welcome you to another episode of Gray Matter with Michael Krasny, a weekly podcast of deep dive interviews with national and international authors, journalists, tech and business experts, artists, scientists, entertainers, and opinion shapers. And you can become a member of this podcast simply by going to graymatter.show, and that's gray with an E. We include your questions and comments, and we cover a wide range of intellectually engaging and timely, stimulating topics, distinguished by high-level content and technical excellence. Our guest this episode is Lisa Krieger, award-winning Mercury News and East Bay Times journalist and also emeritus professor at UC Santa Cruz, distinguished herself as a leading research and reportage-based writer on both environmental and healthcare issues. I'm pleased to welcome her. We've got a lot of questions for her. We're getting questions in from you, but also I have many questions. And as I've thrown questions to her through the years when I was the host of Forum, I always found her impressively thoughtful and well-researched in her answers and responses. And we've got a lot to cover. Good to have you, Lisa.
Pleasure to be here, Michael. Thanks for the invitation.
You bet. Let's begin by talking about avian flu. How concerned should we be or need to be? It's at this point, we're being told it's not necessarily going to go to the general population of people, but a lot of people nervous.
Right. Thank you. And one of my favorite quotes comes from Dr. Michael Osterhelm, who's a great epidemiologist. And he said, anytime you're dealing with H5N1, which is avian flu, you sleep with one eye open. And what he means by that is it's very unpredictable. The backstory on this particular virus is, it's been in wild birds for like 25 years, but 2021, it jumped from wild birds into poultry and some mammals. That was concerning. Last year, we saw it jump into cows, and that's something flu doesn't ordinarily do. So that was a surprise. And then since then, it hasn't stopped spreading, and we're beginning to see it in dairy workers and poultry workers and cats. Cats, dogs. Oh my gosh, there's a big die-off of marine mammals, I think elephant seals, down in South America. So, the short answer is, for the general public, no, not a huge risk. And frankly, there's not a whole lot you can do right now. I mean, we can talk about that. Don't drink unpasteurized milk. Don't touch wild birds. If you've got sick livestock animals, talk to USDA. But for the government, like now, I'd love to explore this further. The time to stop this is now. And there needs to be a really big focus on surveillance.
Well, we're being told, I want to talk about surveillance with you, but we're being told, for example, to be careful about the eggs we eat, aren't we also?
The big concern is raw milk. And there's a concern with eggs, but less of a concern. And I'll explain why. And that is in birds, they almost sicken and die right away. So an unhealthy bird is not going to be laying sick eggs. That being said, if you're cooking eggs, I would cook them well. But what's fascinating about this virus is it behaves very differently in poultry and birds than it does in cattle and in humans. Birds, it's been catastrophic, which is why your egg prices are so high. Birds get sick and they die almost immediately, and it spreads instantly, basically. And that's why you're having really tragic descriptions of what poultry owners are having to do of killing essentially every chicken in a whole giant, producing agricultural area. And then the egg production drops off, and then you need to clear out all the dead chickens, and you need to disinfect it, and then you need to raise new chickens from, eggs from chicks. And that takes time. So that's why there's the egg shortage now. Yeah, all else being equal, it's great to cook your eggs. Super important to drink pasteurized milk.
We're talking about millions of chickens, though, aren't we, afflicted?
Millions.
Yeah.
I think I saw 11 million. And it spreads so easily from barnyard to barnyard with chickens. So it's been a real tragedy.
And it evolves, and that's the thing that has a lot of people concerned. It evolves.
Exactly. It does evolve, and that speaks to the importance of surveillance. But, what we're seeing, and it's fascinating, what we're seeing in birds is actually sort of a different strain than what we're seeing in cows. So what's that tell us, right? It tells us that as it's entering these animals, it's changing and mutating. And we can talk about human illnesses, but the people who've gotten really sick and died, we had our first death in Louisiana, that was acquired from poultry. The cases we're seeing in dairy workers is very different. I think we have like 73 cases in the U.S. now almost the vast majority in dairy workers.
Excuse me, Lisa, there were other health issues, though, with the person in Louisiana.
Exactly.
Yeah.
There were, right, which is, again, characteristic of flu. And there are people with reduced immunity are going to be most vulnerable. So to your point about mutations, we're seeing it change already in real time. And it will continue to change. In cattle, it's looking different than it does in birds. And maybe that explains the different illnesses people are getting. Maybe it's explaining a lot. But yeah, we're watching it.
And lethal in cats, right?
Lethal in cats. It's unclear, again, why it's so devastating to some animals and not to others. What's interesting in cows is you're seeing it in dairy cattle with giant mammary glands. You're not seeing it in beef cattle, and you're not seeing it so much in steers and young calves. Maybe the reason has to do with the receptor where the virus, maybe it selects for cellular receptors in the mammary glands. It's unclear. So much research to be done.
What do we have in the way of vaccinations now?
So we do have vaccines. So people are very familiar with the flu vaccine, and we can talk about that and it's whether or not it's protective. We actually do have vaccines for H5N1 of this particular vaccine. I think there are 25 million doses that are stored that we have stockpiled.
They're talking about giving them to farm workers, in fact.
Exactly. That's exactly what I was going to say. So what they're saying is let's not put it out to the general public, but let's vaccinate farm workers, the people who are at greatest risk. And there are a couple of reasons why. I mean, one is, frankly, the vaccine, it was built off a somewhat older variant of the existing flu virus, but also you want to save what you have in case it does explode and we need to get it out to sick people really quickly.
You were talking about surveillance. What are we doing to monitor, like, genetic changes at this point?
Yeah, so thank you. So there's currently a pretty good surveillance system for flu, but COVID really brought us up to speed as to the importance of surveillance. But that's for H1N1, which is slightly different. So we are monitoring that, and as you're looking for that, you can see H5N1 as it pops up. What we're not doing surveillance for closely, and there are a lot of smart people saying that we should be, and that is watching H5N1 itself in wastewater as it changes over time. And that is, what we want to do is look for the genetic signal that will tell us it's now acquired mutations that will either make it more dangerous, clinically, or more infectious. And that is, it could spread from people to people and people to people more quickly. That's the kind of stuff we really want to be watching really closely, and that's expensive. So a lot of the debate in the research community is whether we can create a more efficient way to sequence the virus, essentially. Maybe we just look for the part of the virus that worries us the most, and then it requires ramping up the infrastructure.
And how does that translate in your mind? What needs to be done to ramp it up, and what should be done?
Yeah,
what should the priority be in ramping
exactly.
it up?
Thank you. So this is the CDC's job. There were several lessons we learned from COVID. I can talk about that further, but one of is the importance of top-down leadership, and that is the CDC putting in a really aggressive surveillance system in states where this is of greatest concern. What we discovered with COVID is, if the CDC is slow or disorganized, it goes to the states, and then it goes down to the counties, and then you've got people on the ground trying to figure this out in real time without the resources, and while they're also dealing with a lot of sick people. So the good news is HHS, I think just this week, allocated, I think about $300 million to increase our preparedness for H5N1. And of that, like $180, $200 million is going to the regional, state, and local programs. So that's great. You're probably familiar, Michael, with Joe DeRisi at UCSF, University of California, San Francisco, who really wants a global surveillance system. And that's, again, something we learned from COVID, and that is these things pop up, and they're just one plane ride away from arriving here. But in practical terms, what it means is certainly looking, when someone comes in sick and you go to your doctor's office and they take a sputum sample or do a swab or something, sending it off to be processed and getting that result really quickly so the clinician, the doctor knows what he's dealing with, and then getting that information to the local health authorities. So then you can do some of the things that we saw with COVID of containment, and I know that was an imperfect success, but yeah, or deploying vaccines, as you mentioned earlier. So yeah.
Is it likely that there's a certain route of transmission that we can prognosticate about at this point?
Yeah, fascinating. So what's interesting now is with poultry and with cattle, it's all about surface-to-surface transmission, right? So the person in Louisiana who got really sick and died, the presumption there, and again, you were right, he did have other things going on medically, but the presumption is he was handling a dead bird, so was exposed to a really high dose of the virus. But he was handling it, and then same with our dairy workers, the folks who are getting sick are the ones who are milking, right? So they're having contact with the cattle themselves and with the teats and the milk.
Mild symptoms, though, at this point.
Mild symptoms, right. But what happens, which is really interesting with flu, is that it can jump from this type of contact transmission to respiratory transmission. And that's how we give the flu to the H1N1. That's how we give it to each other, right? So that's another thing they're worried about, is that it does have this well-known, well-established habit pattern of going from contact to contact to respiratory transmission. And that matters, of course, right, in terms of how we respond. I mean, we're all familiar with masking up, and that's very different than wearing gloves or, cleaning your groceries when you bring them in.
Do you think we should be masking up?
This all gets to risk tolerance, right? I think it's certainly premature to mask up now for H5N1, but COVID's still around. Flu is very much still around. And then, of course, there's, RSV and everything else. So, it's very much assessing your own personal risk, your own personal health history, and where you are. Are you in a confined space?
We also have a new administration coming in that's known to be anti-science, or certainly has that association in terms of past history. Have any thoughts about that or reflecting on that?
Thank you. Yeah, glad you brought that up. When we were talking about how do you respond to pandemics and the importance of top-down leadership, it absolutely worries me. Absolutely worries me. And A, anti-science, and B, we saw COVID become so politicized. I mean, it wasn't initially. I mean, all of us, it wasn't that long ago, can remember the vaccine rollout with COVID. And there was Trump administration, and he did a stellar job. That whole Operation Warp Speed was historic in terms of how quickly we were able to give those contracts to the pharmaceutical companies, get them in clinical trials, changing a lot of the approval mechanisms, identifying what worked and getting it out there really quickly. That was an unqualified success. And then it became politicized, right? And then things went south. I think, circle back to our home state, California, I think a lot of credit should be given to the willingness of Sarah Cody, for instance, Santa Clara County, for identifying really, really quickly that we were in the bullseye because of all of our incoming flights from Asia, and closing things down, sending people home. And our governor also responded really quickly. So, yeah, leadership matters big time. And then also, we can talk about this in greater detail, how much you believe in the scientific process for vaccines. How much do you believe in it for pharmaceuticals? And it's going to be interesting because RFK Jr., should he be confirmed, and that's we don't know how that's going to play out.
That's pretty scary too, actually.
It's very scary. However, pharmaceutical companies have a lot of weight in Washington, D.C., as do the food companies, which he's also taking aim at. So, there's some guarded optimism that sanity will prevail and that the science will speak for itself. But we saw a really big change and a real big fumble with COVID when CDC stopped trusting its leaders, and the decision-making was taken away from CDC, frankly, and sent back to HHS, which did not have the expertise. And frankly, I think there are blood on their hands. There were lives lost because of that.
I think you're right. And I'm going to go to a question from Sally in Tulsa, Oklahoma. She's asking how concerned we should be about H5N1. I think you've answered that very well. But then she says, if it spreads like COVID, what would be the effect?
Very similar to what we see in the really serious flu pandemics that we have occasionally. And 1916, 1917 was horrific. Deployment of vaccine hopefully will blunt its impact. And we also have Tamiflu, which appears to work. Certainly we need more than that. But I think the people we would lose first it's very similar to what we saw lost in COVID, and that is the people with weakened immunity. So it'd be the elderly, children, and people with comorbidities, other illnesses.
Yeah, I'm afraid that's pretty good prognosticating. Unfortunately, let's hope it doesn't necessarily occur, especially in the widespread way that it could occur. I'm wondering what your thoughts are, though, also about the fact that this seems to be, at this point at least, you were talking about the wastewater and so forth. A lot is centered in California with H5N1.
A lot centered in California. Michael, something like 2/3 of our dairy herds are either currently infected or have been recently infected and are going through all the quarantines and all you need to do to get clean and back up and running. Wastewater, it's super interesting. Everyone's heard of preprints. These are the papers, you don't sit around and wait for a journal to run them, but you post them online. There was a preprint looking at our wastewater, and they're saying a lot of the denatured, inactivated fragments of virus that we're seeing there, and it's all over in the wastewater, is from milk that's being poured down the drain, which, it's pasteurized. You don't have to worry about it. But it's also in birds and then, of course, in other animals. So, yeah, California, frankly, kind of saw this coming, and the California Department of Food and Ag was really proud of itself for a really long time of protecting our borders. So I don't know if you remember, but very early on when the initial cases were seen in Texas and then I think Minnesota or Wyoming, having trouble remembering, looking back, and indulge me here, it was the presumption is it was one case in Texas where it jumped from a bird to a cow. That's all it took. We call these zoonotic spillovers, they call them, where that spills from one species to another. And then because cattle are moved so much, it traveled throughout the Midwest. Anyway, California Department of Food and Ag was pretty proud of having border control. So if you wanted to move a cattle, you needed to have proof of papers showing they'd been tested and were clean and all of that. The rumor in the dairy community is that the cattle were sold in the Midwest to someone in the Midwest, and then they were moved back. Either the sale was rejected or something else went on. For whatever reason, it slipped under the radar, and pretty much in 2 months, went from like 3 or 4 dairies to we're now up to 704 out of about 1,000 dairies, 1,100 dairies. So, yeah, so how does that happen, right? What happens with dairies is that milk trucks travel from dairy to dairy, veterinarians travel, farm workers travel. It's, we're all in this together, right? And it's very much of a network. And it's hard on these dairies because then you've got to, every time someone comes and goes, you need to have them wash their equipment and wash their boots. And
excuse me, it's spreading to all these different dairy herds too, right? All
exactly.
Across, yeah.
All across. Yep.
So this is scary stuff, especially and just in terms of the effect it's having possibly on dairy and eggs, and we've talked about that. I was going to ask you about bird poop, which is all over the place. Every time I take my dog out for a walk, I see more bird poop, it seems, than the time before.
Right.
The real question is,
right.
What kind of effect is that having? Or do we know?
We've got some pretty good theories, and the main one is unless your dog's rolling in it, unless they're eating a dead bird, which I recognize happens, that probably unlikely, but you absolutely don't want your dog handling or picking up dead birds. So yeah, and then with cats, do not feed them raw milk because it's pretty much 100% fatal. Or I'll put it this way, if the milk is infected, it has a really high fatality rate. Now, will you catch it from your pet? No, because it hasn't yet developed the capability that we've seen to jump from dogs to people, cats to people. But we're seeing it from cows to people, and we're seeing it from birds to people, so we need to be paying pretty close attention.
Let me go to another question here, just a general question from Tom in Phoenix, and thanks for the question, Tom. He wants to know your opinion, Lisa, about what the most underreported story in science or health today is.
So I've got to be honest, and it's really hard to get the public's attention with climate change. It's just really hard. In fact, there have been analyses done where if you put it in the headline, people may not click on it, or if you put it too high up, they may not click on it.
We have a president-elect who doesn't believe in it. Just for starters.
Yeah, exactly. So the question is, how do we make that story compelling? And certainly, the LA fires and all the heat waves and other storms help with that. But I do think the whole story of zoonotic viruses, and that is viruses that jump from animals to humans, needs further publicity. Just because, we're such a global world now, such a global economy, that things, the flu outbreak in 1917, soldiers came back, they were shipped back from the trenches, brought it with them, and there have been analyses done of cities that responded quickly had far fewer fatalities than others that didn't. I think just amping up our surveillance system is a good one. Boy, there are lots of other, I love astronomy, and it's often hard to get those stories told. Detecting oncoming asteroids, all of that. There's so many interesting stories out there. I love covering science. We joke that it's the wow beat. Like every story is like, wow. But so much of what's happening in science now is just progress, right? It's good news. We're just getting smarter and smarter. And the more you learn, the more interesting everything becomes. And I love readers who care about science because it really matters. And you look at what we're doing with stem cell research and CRISPR-Cas9 and gene editing. These are diseases that didn't have a prayer until we launched the Human Genome Project. And then people like our Jennifer Doudna became engaged in private startups of like, how do we move it out of the lab and into therapeutics? There are many diseases that just affect a small number of people, but they're catastrophic, and you could go in and fix some of these. I love medical writing, love science writing for that reason.
Well, CRISPR is leading us in all kinds of avenues and paths that we didn't believe possible. It's extraordinary where it's been leading us, and Jennifer Doudna,
it's absolutely extraordinary.
Suggesting has been central.
Yeah. The more we learn about the human genome, the more we recognize the challenge ahead of us. So, in the old days, we used to think one gene, one disease, right? You had a gene for cardiovascular disease or a gene for cancer. And now we're realizing that many, 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 many genes involved. And then they all have their own relationship with the environment and how they respond. And Michael, I know you're familiar with this of gene expression, turning them off and on. But there are those diseases where it's caused by a single gene, that one mutation, and it becomes fatal. Those are the diseases where we can deploy CRISPR and make a huge difference. Sickle cell and cystic fibrosis are two of the shining examples of that, particularly sickle cell. And then, another conversation, but then it becomes a health policy question, right? Can we afford to offer CRISPR or gene editing in general to everyone who has sickle cell? And as a healthcare system, what do we do about that? It's very expensive. And, certainly there are ways to bring the cost down. But this is personalized medicine, right? And this is what we wanted, right? We want personalized medicine. We want medicine that's tailored to your specific genome. But that's really expensive because they take your cells and your genes and then fix them and reintroduce them. And then they start taking over for the ones that are not healthy. With sickle cell, particularly, it'll start producing beta hemoglobin. Lack of it is what's killing people. And other diseases like diabetes and others, where there's more of a clear-cut genetic solution, and others it's proving to be a whole lot harder.
Well, you also live in a system where a good deal of the research depends on what the outcome is going to be in terms of dollars, and unfortunately, there's too much of an integral connection between those two, and I think we've been held back in many ways because of that. But that's a whole other discussion.
Excellent point. And the other thing, and I know you know this, Michael, is that these things are in silos, right? We see how much it costs to treat someone with sickle cell, and that's daunting. But what we're doing is saving the healthcare system years and years and years and years of treatment. So we're not good at comparing those costs very well, because the insurance company who's paying for your sickle cell cure today may not be the health insurance company that's covering you when you're 55 and you're having a million complications and a lifetime of pain and transfusions. So it's a challenge.
Big challenge. And I want to talk with you about fires, as I promised. But first, here's a question from Jeff in Miami Beach. He wants to know, why does the CDC seem to be prioritizing warnings about norovirus?
I am not entirely sure. I mean, norovirus, I think, can be transmission. My understanding is it's through infected food and other things you eat and drink. You can catch it real quick and interrupt transmission. And it also has a very high morbidity, mortality rate. It's not something like the cold. You get it and you overcome it and you move on. It's a very well-established sort of chain of transmission that can be interrupted. So I think it's a pretty easy target, frankly. But it requires catching it and doing something about it.
So let's talk about fires. You'd mentioned before, I don't want to be too California-centric here, but the role of climate change, and perhaps you would hope that people would be even more sensitive and more aware. But like you say, it's a problem for all journalists to make people more sensitive and more aware. And it doesn't seem to work just to talk like Cassandra about all the heavens falling and Chicken Little and all that. It seems to be an important and vital necessity to educate people. But I'm wondering what you think about just some things that we are wrestling with right now, like why the winds are blowing so hard, for example, in January in California.
Yeah, this has been pretty extraordinary to watch. So winds always blow really hard between October, November, December, and January. October and November is when they typically cause problems. December and January here in California, they don't. And the reason why is because we have so much rain, right? So if you look at the winds versus precipitation, you really only have 2 months that you typically worry about. What happened this year is Southern California didn't get the precipitation. Northern California did. So we're having essentially the identical winds, not quite as strong, but we've got the Diablo winds that come. And no big deal, right? Trees fall over. It's a mess. But we're not getting ignitions. And so what happened was the winds and the drought coincided with each other. The whole wind thing, it's happened since the beginning of time, and it's actually pretty interesting for people who are interested in meteorology. So, the jet stream shifts over the course of the year, and we get this high pressure system that's over the Great Plains, and air pressure, it's a lot like water, where water wants to find its own equilibrium. So high air pressure rushes over the Sierra Mountains towards low pressure, which is in the Central Valley. And it just has this cascading effect. And that's what wind is, right? It's the wind rushing from high to low pressure. So it's very much a seasonal thing. It's happened since, for millennium. But the risk, of course, is, when it coincides with droughts. And also, there's so many people living in California now. Like, what, Michael, 40 million or something. And you need a source of ignition, right? They talk about the fire triangle. So that's the third part of the triangle, and that is somebody starts it. And we don't know what happened and we're not talking arson, but
we might be.
When people are out and about, they start fires. It might be.
Yeah.
It could have been random hikers on New Year's Day. It could have been fireworks. Maybe it was a power line, but yeah, it could have been. So the more, it's just a math problem. The more people you have, the more likelihood of ignition, and the more people in harm's way, which is why when actually the dollar amount for these fires gets tallied up, probably be the most costly ever.
Well, we have a new app for tracking wildfires, which is, along with other technological advances, can at least make us more hopeful. But at the same time, things are moving along a trajectory with population, as you suggest, and also with climate change that are very disturbing.
And Michael, I don't know if you've been following what's happening in Paradise. It's, for those who aren't Californians, this is where the campfire was, and it essentially wiped out.
It was incinerated, basically.
It was incinerated.
Like Palisades. Yeah.
It was incinerated. You go back there now, and they're trying to build a fireproof town. It's extraordinary. Really strict building codes, a lot of steel, a lot of concrete. Sadly, it's young the people who lived there before have largely left. A lot of them are older, and it takes a lot of resources to rebuild, and it takes insurance coverage to rebuild and all that. So there are a lot of young families moving in who have never lived there before, and there's a real commitment to doing it right. And I think there's a lot we could learn from that. So yes, California's getting crowded and hot and windy, but I think there are things we can do. I mean, clearly, when you have something of what's happening to Los Angeles right now, there's, embers are flying for miles, and it doesn't matter if you've cleared 5 or 10 feet away from your house. That may not be sufficient. But there are other things we can do. And there's still a whole lot of worry about towns. And this is, Colorado, it's all over the U.S. West, of towns that are isolated on ridges, and no good way to get in and out in a hurry. So I think there's a whole lot of smart people looking at how do we, on the assumption that we will burn because fire is part of our natural history, they call it the fire regime. How do we learn to live with fire and survive fire, and how we build our cities?
What about the blame that's come down, particularly from President-elect Trump, talking about water management and the smelt and water going into the Pacific and all of that? Your response?
Yeah, thank you. Southern California doesn't get its water from the Sacramento Delta. Completely unrelated. It gets its water from that aqueduct that runs from the Owens Valley east of the Sierra Nevada, and groundwater and the Colorado River. So it imports its water from different places. It's not getting it from the Delta. But the other thing is it has plenty of water. I mean, that's the crazy thing. It has tons of water stored. What happened with this particular fire was a local problem. The city's infrastructure wasn't designed to respond to a fire as large as this one, and the local water storage wasn't adequate. Now, can you ever have local water storage that is capable of responding to something like this? I mean, it would mean what, like tanks and reservoirs all over the place? I don't know. I don't live down there, but I have a whole lot of faith in the Metropolitan Water District and keeping water flowing into Los Angeles. I mean, a lot of Californians think it gets too much water, but yeah, that wasn't the problem here.
Talking with Lisa Krieger, and we'll be taking a few more of your questions in just a moment, but I had said I wanted to talk about COVID with you. We've got a new variant now, and I'm wondering what your thoughts are about, its circulation and what we're learning about COVID, and particularly long COVID.
Right. Yeah, thank you. It's funny how quickly one virus replaces the other in our attention. It's absolutely still circulating now. The good news is it's pretty low. Activity is pretty low as opposed to flu. Just your, H1N1 random flu is actually pretty high. So what we've got right now is a subvariant. Everyone's familiar with the variants. It's called XEC. It's a subvariant of the Omicron that I know people are familiar with. The good news is that there's really no evidence that this causes different symptoms or worse symptoms or more severe symptoms, more severe disease. And there's also no evidence that it's more transmissible. So those are the two things you always want to keep in your mind when you hear about a new variant. Is it changing on either of those two parameters? Does it cause worse illness, or is it more easily transmitted? And the good news is this one is not. One distinguishing characteristic of this, which is super interesting, is it's called a recombinant strain. So it's kind of a hybrid that resulted from a rearrangement of two of the other existing subvariants. So it just reminds us that this can happen. The theory is that someone was actually infected with both of these other strains, and then this came out of it, which actually is a point I wanted to make about avian flu. We can talk about that, of recombination. Anyway, COVID, yes. And the good news is also that our vaccines still seem pretty well matched for now. And that changes every year, which is why COVID vaccines will continue to be, for better or worse, part of our life. But what we're
How many
not...
times a year? 2 times a year or just once a year?
They would love twice. And the reason why is that your immunity, your protection tends to fall off a cliff at 4 to 6 months. But, trying to get people in for vaccines twice a year is just a really big ask. So I think the hope is that when you go in every fall, or late fall, you go in for your flu vaccine, you get your COVID vaccine as well. And, that'll protect you during the winter months because you will have strong immunity for up to 4 months. And that's when people tend to cluster inside and cough on each other and be together and all the
How
wonderful.
do you know, though, it's still a big question, I realize, but when you have a cold or you have flu symptoms or something, how do you determine if you do or don't have COVID?
Yeah, thank you. So every respiratory virus, you've got sniffles and headache and fatigue and all of that. Flu is characterized by a super high fever, 103, 104 degrees. That's classic flu. With a cold, you very rarely get a fever. And with COVID, it's less of a symptom as well. But you go on into your doctor's office and they will test if the profile seems COVID-like. They'll test and they'll send it off. Cough is also pretty characteristic of respiratory illnesses. RSV, which is going around, seems to have a really wet, distinctive, and forceful cough. People with RSV are unlikely to feel some of the muscle aches and the fatigue that you get with COVID. Boy, what else? A different time of onset, which is interesting. If you're exposed to someone who's sick with the flu, you'll probably get it within a day. It's quick. And colds and COVID are slower onset. I realize that only helps in retrospect, but yeah.
Well, what do we learn now, particularly with respect to long COVID? I mean, we have certainly advanced in our knowledge, but can you sort of crystallize it for us?
Yeah, still no rock-solid theory about exactly what it is. There are two theories that are the strongest, and they're both really interesting. So one of them's they call it viral persistence, and that is how much of the viral proteins or other genetic material are you still carrying around with you after you've had an infection. So for a lot of us, particularly if you've got a strong immune system, it'll knock it down and life goes on, no big deal. In other people, it can linger. And the thought is either your immune system wasn't able to knock it down adequately and you're essentially still walking around with a viral infection that you haven't been able to kick, but in a very low level. There's this amazing study out of Harvard that found up to a year they were finding in people with long COVID, they were able to isolate the virus, which is incredible. The other theory, which is also really interesting, is that it's a little bit like autoimmune disease, and that is infection can trigger your immune system to dysregulate, basically. It's overreacting, and once you turn it on to fight off the virus, which is what we want it to do, right, it stays turned on. So all of these things, when you get a fever with COVID or flu or whatever, what's making you lousy is your immune response. They call them cytokines that are going after the virus. So your immune system gets dialed up and it doesn't get dialed down. And then you're sort of walking around with this really dysregulated immune response. So they're working on both of those because they require different strategies, right? If it's viral persistence, we need better antivirals to help get it out of your system. If it's a immune dysregulation, that's going to be more challenging. But other viruses do very similar things, which is interesting. I mean, some people, after the flu, sometimes it takes a while to get back on your feet. It's similar.
You mentioned the antivirals. They're going to be used for a while presumably with avian flu, aren't they?
Yes, exactly. They're really, really, really important.
And a big question from Susan. Thank you for the question, Susan, in Austin, Texas. How do you see the intersection of artificial intelligence and healthcare shaping the future of medicine?
In terms of healthcare, it's controversial. You don't want AI replacing your doctor, of course. But there are some things that AI is just stellar at. I mean, one of them is looking at cells, right? So let's just say you go in, let's say with a woman, you have a pap smear, it gets sent in. You currently have people at microscopes looking at the characteristics of your cells to see if they look malignant or not. Really imperfect system. That was actually one of my first jobs out of college. Friday afternoons, you're really tired. A lot of that is automated now, of getting machines to look at cells. And boy, if you can train AI, which they're doing, to detect to identify any cell out of millions that looks uncharacteristic, doesn't fit the profile, it's got, a ragged shape to it or something, and flag it, that's so much better than people will ever do. And also, so much of medicine is data-driven now. So let's say all your health records are automated, and we know it's going to be much better at linking data with disease. So I'm just making this up, but let's say there's a outbreak of a disease, and you can go back and automate all the health records and say, is there one thing that all these people had in common that links them to this? It's just stellar at processing vast amounts of information. Way better than people will ever be. So I'm optimistic in that sense.
In that sense, I share your optimism, and that's very good to hear. And you've been talking about the progress and really sounding upbeat about a lot of the progress we've been making. Let's talk for a moment about the new HIV drug, which is injected a couple times a year. That's in that same category.
It's absolutely in that same category. And Michael, you remember the worst of the AIDS epidemic. We're losing 4 to 5 people a day in San Francisco. And then progress has been very incremental, right? We had some of the antivirals that were good, but only for a while, or only partially good. Then we had the combination therapy, which was brilliant. David Ho out of UCLA, and now he's in Manhattan, where you would attack it with 2 or 3 different antivirals to hit it at different points in the life cycle. So more recently, there's a pill called Truvada, which if you take it every day, it'll prevent infection if you're exposed. And that's been a game changer for people who are adherent, who have the resources and the ability to take a pill every day to protect themselves. What's on the table now is an injection, and it's made by Gilead, which is in South San Francisco. I'm going to mispronounce it. It's called lenacapavir or something like that. Anyway, twice a year you get an injection, and it absolutely prevents infection. And you think about what that means for other parts of the world where people don't have the ability to take a pill every day, or there might be a stigma, or they can't get it, or whatever. It's fascinating. It seems to work through 2 different ways. One is it prevents the virus from invading the nucleus of a cell, of your T cell, your immune cell. And the other is if the virus does infect that cell, it prevents it from replicating and producing progeny. So, it's been so long, since 81, where we've been talking about, is there a cure for AIDS? Is there a vaccine for AIDS? This is the closest thing we've got, and it's pretty darn good. I think it's like 96% effective. It's taken 40 years, but I'm really optimistic. It's wonderful.
I welcome your optimism and your enthusiasm, but here's a question that makes us think at least maybe in another direction. It's from Jeff again, who says, is there concern people are just pandemicked out and might be even less likely to follow all the necessary safety precautions?
Oh, great point, Jeff. Absolutely. It's apathy, right? I mean, you can't stay on high alert all the time. So I think that gets to the importance of messaging with public health officials. When it is a DEFCON, all hands on deck, shut things down. And when is it just something, get vaccinated, which even just getting vaccinated once a year would be great because the vaccination rate's actually still pretty low right now. So, yeah, I think there's absolutely that concern. And just creating trust in science, right? Trust the process and that the messaging, we can't yell Chicken Little every day.
Well, fortunately, we have journalists like you, and we've been very fortunate to have you out there, shall we say, a kind of passionate and sanguine way that you've been able to bring our attention to so many of these issues and the kind of enthusiasm you have for what you write about. What are there some golden lines or some positive lines, optimistic, with respect to climate change? You went to Azerbaijan, I think, didn't you? Did you go to
I did not, sadly. Would have loved to have, although there was a lot of frustration.
Well, I should mention to people, when I made that reference, I was talking about the Major Climate Change United Nations Conference.
Yeah, exactly. Yep, Azerbaijan, COP29 it was called. The focus on COP29 was how do we support developing nations? And that was a bit of a qualified success. There's a financing plan now. It calls for $300 billion per year to support developing nations. These are countries that are going underwater, like as we speak. Now, of course, there's huge criticism from those countries that is just a drop in the barrel. They're estimating they need $1.3 trillion per year. So really just part of it. But it's a start. My larger concern, to be honest with you, is the new administration's willingness to renege on a lot of the commitments that were negotiated there. They're going to need a lot of America's help with this, and a continued commitment to reducing emissions among the developed nations. And that takes focus and it takes funding. There's actually some concern that the Republican-led Congress might stop funding. This is unintended consequences, right? If we curtail funding for Ukraine, then all the European countries will need to pour money into that, and they'll have less available for climate. All that being said, 2024 was the warmest year on record, according to the World Meteorological Association. And July 22nd, those of us who remember some of what was going on there this past July, was the hottest day ever recorded on Earth. So I think we have people's attention, and it's not just heat, right? It's, instead of snow, you get rain. So then you have these giant floods, and we saw in Nepal and elsewhere. And there's this volatility of the climate and a less of a margin of protection. So I would just encourage everyone to continue pressing. I'm pretty proud of what we've been able to do with renewables, but we need to continue pressure on that and dial that up.
Well, the COP23 meeting did have some fruitful results, and that they came up with some tech rules, especially tech rules for international markets under the Paris Agreement. But I don't know about the teeth in that.
Very good question. It's diplomacy, right? That's what we're relying on. It's not like there's any rule or regulation you can put globally. It's the power of the negotiators and the diplomats to convince leaders that what they agree to actually gets put into policy and practice.
It was just a confirmation hearing for Chris Wright, who is head of Liberty Energy and who is, essentially made a fortune off of fracking. Going to be the energy secretary. He he gave some words about the importance of climate change, but you have to wonder, where's he going to go? What's he going to do? How much can he be trusted?
Right. I mean, the silver lining, or the bright spot, as you mentioned earlier, is that a lot of this movement has already happened with power companies and some governments, and they're not going to go back. I mean, the business world sees where the future is. They're very much motivated by markets and growth, and that's where they're seeing the growth in the markets are in renewables and sustainability. So, policies influence that, regulations influence that. That being said, I don't think you're going to have a complete reversal. I mean, you look at how much of California's energy now comes from renewables. They're not going to go back and reverse that. I mean, it's got a life of its own at this point.
But you see how all these tech people are lining behind Trump. I mean, they're being pragmatic, I suppose you could argue, but at the same time, they're all giving money to Trump and his administration, and they're all going to be at the inauguration.
Yep.
The big titans.
Yep. Super worrisome. What's going to be interesting to watch is Elon Musk. And I know people have very divided feelings about him, but he he strongly believes in electricity and EVs, and he's committed to that. So to have him so close to the president will be super interesting. I mean, he does believe in climate change, and he's bet his fortune on it. So that'll be interesting. Some of the others, social media and others worries me, of course, especially the media worries me, having investors there. But it's going to be interesting to see how it plays out when push comes to shove. EVs, again, the car companies have committed to EV, and they're well downstream with that. And again, they're not going back to the all-gas, 12-mile-per-hour pickup trucks.
But they're going to metals that are in some ways more harmful to the environment.
This is true. And great question about mining and what do we do about that? Because we need it to some extent. Can it be done more safely? We certainly don't want over-reliance on China. So is there a way to find these things domestically? Is there a way to create them? Oh my gosh, there are like so many smart people at Stanford that are looking for better batteries made out of different materials, more efficient batteries, longer-lived batteries. I have a fair amount of trust in science and research that if we let them do what they're great at doing, they'll start coming up with solutions, better solutions. But they need support.
from your lips to whatever power, divine or otherwise, ears, let me first of all thank all who joined us for this episode of Gray Matter with Michael Krasny, which you can listen to on Apple, Spotify, or simply go to our website at graymatter.show. And if you haven't yet become a member of this podcast, again, I invite you to join by going to the website, graymatter.show, where you can find previous episodes, and that's Gray with an E. Also invite you to mail any reactions or suggestions you may have to me at mkrasny@graymatter.show. I want to thank our team of Alex, Shannon, Chad, Kevin, Jeff, Colleen, Tanya, and Lori. And a special thanks to this week's guest, Lisa Krieger. So good to have you with us.
Thank you, Michael. I love your curiosity and expertise. And thanks to all the listeners and your interest and commitment in science and medicine and research. Thank you.
And thanks and much gratitude again to you, Lisa. I'm Michael Krasny.
Bandwidth for Gray Matter is provided by CacheFly at CacheFly.com.